Okay, girls, let's go. Here we go. So tell me what you got wrong. Tell me what you got wrong in short. Give me the ball. Now, in case you don't understand that, look on the left of the chart. EYTH means Pythagorean theorem. So it's 90 degrees. It's the only angle you can use the Pythagorean theorem. When it's 180, you subtract. So that's easy. 3, 4 minus 3, big minus small. Range is now, can you do small to large or large to small? Either one. But I'm going to tell you something for the test. Ready? Let's add something for the test. Ready? So if I ask you on the test, for instance, ready? What's the force when you go from 180 to 0 degrees? What will you answer? Will you answer 1 to 7 or 7 to 1? You answer tough, what is it?
7 to 1.
Well, actually, 1 to 7, because 180 is subtract, isn't that right? 180 is subtract. So if I did this, then you better say 1 newtons to 7 newtons, okay? Because that's what I do on the quiz. So if I ask you the range, you go from 180 subtract to 0, you add, so you say 1 to 7. But I didn't mention what I wanted. I didn't say, 0 to 180 or 180 to 0.
Which is it? Oh.
So if I ask you, if you've got 3 and 4, if you went from 180, that's subtract to 0, we add. So if I just say range and I don't specify, well, then you can say big, small, small. Okay? Yeah, I gotta specify. Okay? This. So everybody's good on this first part? So on the quiz, you'll have to draw, you'll do a tail, go ahead.
This is kind of unrelated, but when are you doing extra help this week?
Extra help will be, tomorrow, Tuesdays and Wednesdays, so that's why the only extra help, yeah. What's that? 1A, well, now this first vector is tail to tail, because this is the head of a vector and that's the tail. And when you do tail to tail, you must make a parallelogram. See my parallelogram with the dotted line? And the result is the blend of the two. It goes right in the middle. So it goes corner to corner. Make sure you stop at the corner, don't go beyond. You clear on that one? Now, that's how you do the first one. This one is head to tail, the second one. Arrow head to the tail of the other vector, and all you do is complete the triangle. So you'll have 2 examples. You'll have to do a tail to tail, just parallelogram, and you'll have to do a head to tail. All right, so number 2, greatest result is 0. You know that already. We add them. And the smallest result is when the angle is 180, you subtract. Okay, and now you'll be able to draw components using that right triangle method. A vector that goes down and to the right has a right vector and a down vector. I did 1 centimeter equals 2 newtons, so it would fit. It was not too big. So I chopped it in half a 1 to 2 scale. I used my trigonometry for the vertical component. Yep.
How do you know it's to the right?
Because it was east, south, east. East is the right.
Where is it?
Well, you know what I said? Well, how do I know that to draw the vector to the right?
Yeah.
Okay, so it says 6 newtons, 35 degrees south down of east, right? South of east, down from the east, down from the right. So you have to be able to do that. I think you're pretty good at that. You girls can do all this stuff, can't you? I use my trigonometry to get the perfect answer. Yeah.
Can you run up to 5?
Well, we're going to little by little start to talk about rounding rules. But now, just give it that really accurate number. Well, we will talk about rounding rules when I start to feel you're really kind of getting comfortable with physics. We'll start to have a discussion. You know about significant digits?
Yeah.
We'll have that conversation. Well, I hold back on it. So you just give me that big, really detailed number. But don't go across the page or anything. Okay, girls? So I know you're pretty good. What's the largest vertical component? Well, 100% up, or, hold on, let's add to this. It can also be, hold on. That's also a really large vertical component. What's a really large horizontal component? Completely to the left and completely to the right. Completely horizontal in these directions. Okay. Class, is that good, girls? 4 is good? Classic regions question. What happens to the size of each component when you go from 30 to 45? The vertical will go up and the horizontal will go down. Why? Let's add this. Oops, now we'll do this. Ready? Closer, when I get closer to 90, V goes up, vertical goes up, and closer to 0. If I go closer to 0 degrees, horizontal goes up, because 0 degrees is all flat and horizontal. Okay, yeah.
For number 4, could you say like 90 degrees and 0 degrees?
Oh, that's pretty good. Good, yeah.
Can you explain 4?
For which one, the vertical component is the maximum value. No, see those 2 answers? That's completely vertical. That's 100% vertical. Can't you see that? These 2 arrows are 100% vertical. They have the maximum vertical component when it's 90 degrees. You see that? There's nothing horizontal about that at all. Let's look at the horizontal component. There is nothing vertical about those 2 arrows. Okay, because I like the way you said that. This is 0 degrees and 90 degrees. It's terrific. Good. Okay. Let me do this with this. This is 90 degrees and 0 degrees. Okay. So this is a classic regions question. I hope you know how to do that. What do we say again? Let's write it again. Closer to 90 degrees. Oops, sloppy. Closer to 90. Vertical component goes up. Closer to 0. Horizontal component goes up. Okay. Alrighty. So when the angle of vector makes with the horizontal increases, the horizontal decreases and the vertical increases. Why? When the angle increases, isn't it true you get closer to 90 degrees, which is the maximum vertical? When the angle increases, you're getting closer to 90 degrees, so the horizontal will decrease, it becomes less horizontal, more vertical.
Oh, wait, you said the horizontal.
The horizontal decreases,
Oh,
so closer to 90, the angle increases.
I didn't understand what it said, like, I thought it said like the horizontal.
Yeah, be careful, because this is where the regents will say, thank you for pointing that out, because people do get confused. What are all angles measured from? The horizontal, dotted line?
Like, I didn't know it was like from the horizontal line. I just
But I'm so
thought it
glad
was
you-
horizontal.
Yeah, so glad you pointed it out, because you see what she's saying, and I'll just get you, listen to what she's saying, because a lot of people get tripped up on that. It's the angles are measured from the horizontal dotted line, so as the angle increases, the vector gets more vertical and less horizontal. Good, sure. How could 80, this is a great question, it'll be on your quiz as well. How do you do this one? It's really quite easy once you get it. Ready? Could they ever be in a steady equilibrium? What you do is you pick any 2 forces. I just happen to pick these 2 and find the smallest, subtract the biggest, and 2 doesn't fit within that range, so these 2 forces could never be in equilibrium. It's so easy, add and subtract, yeah.
And 180, when I try 180, it's a smaller one.
Good, smallest, 0, it's the greatest result.
Okay.
So how do you do this again, Z? Take any 2 forces, add and subtract, find their range, and if the 3rd force doesn't fit within that range, they could never be in equilibrium.
So I can do any.
Any 2 you feel like? I did the first 2. You could do, watch, check this out. See, look, I could do 4 and 2. 6 is the biggest, 2 is the smallest, and 8 doesn't fit in that range. Any 2 forces you feel like doing. Add and subtract, look at the 3rd. Does it fit within the range? No, cannot be in equilibrium. What does equilibrium mean? It means balance, and F equals 0. So you have now 2 tip sheets for the for the test. You also have that big drawing sheet, so you have a lot of things to reference. Also, get out the lab that we've been working on, and we're gonna finish. We're gonna do one more thing on that. Get out the lab that's full. Hold on to the bathroom now. Talk about that, okay? Sure. Could you get us on that? No, not that. The other one. Thank you. Everybody get out. It says resultants and equilibrium lab. You take it out. So you've already done the whole first page. Now, I want you to know, on page 2, we started it, but didn't finish it. That's your job tonight. You don't have much of a homework at all. You have the first picture, finish the first page, finish the second page. What do you do? Work to do. Now, all go to the, let's see, 1, 2, 3, what page? Looks like this is right. What page? What page? Thank you. Okay. Okay, neurons, are you ready? So I have look at that setup in the corner. That weight is in a state of, what's it called? A state of equilibrium at rest. How many forces are on, let's see, a good little review. How many forces are on that weight? How many forces are on the weight? How many? Not 2, but one is invisible. 3. Who says 3? 3. What am I talking about, that invisible force that's on you and me? Gravity. Show me with your thumb. Everybody show me which way does gravity always go? Straight down, perfectly straight down. How do I know that? Because I take a penny and I let go, those go straight down. Okay? So there are 2 forces coming from the string, and they go this way, right? Then there's one weight force going down. Let's see how big you are. How does the result of those 2 string forces compare with the weight force? The resultant of these 2, how do they compare? What must always be true? Well, yeah, very good. It's the result is equal but not beautiful. Because it's in a state of equilibrium, the resultant, we did this already, the result of these 2 forces have to be equal but opposite because we're in a state of equilibrium. So, are you ready? So, I need somebody, would you give us the readings on, let's see, you got a Brown scale. Who had the Brown scale? Did anybody have Brown scale? What was the division of the Brown scale? Like what? Brown scale division? Yeah, so everybody on that page, everybody write that division, I think it's on the top, let's take a look. We had a Brown scale, so on the, it says green scale, let's cross out green. Remember, we're on a page that's empty. So ready? So the last drawing. Could you try to cross out green and write brown? We have a brown scale. Here it says green scale with a brown scale. And the divisions are 0.2 each division. 0.2 on the brown scale. Remember, when you're given a scale, the first thing you have to do is like, what is each little division equal? And we were told, I think she's right. That's 0.2. 0.2 newtons. Good. Look for you. Look at me. This is for you. I said 0.2. That's not good science. 0.2 newtons. Thank you. I'll tell you what. Score 1 for you. 0.2 newtons. Good. So I'm gonna. Abigail is a very good, John is a very good measurer. So, John, would you get the values of both those scales? She's a very accurate person, to be honest. So she's going to give you the readings on the left and the right. Listen, everybody, every division is 0.2.
2.4.
Okay, 2.4 on the left scale. 2.4 on the right scale. 2.4 what? Newtons, good.
Is that one right?
So that's what you write on the, if you're on the top, I don't need to be ready. So force 1 is 2.4 newtons, and force 2 is 2.4.
Is a scale?
Yeah,
Is a scale 1 centimeter, 1 Newton?
the scale is each division is 0.2.
Oh.
And then now we're gonna do a drawing. Could you also tell me, should we use a 1-to-1? Everybody look what 2.4 looks like. Do we have to chop the scale down? Let's use a 1-to-1. Let's see, what do you think? I think we can use a 1-to-1, correct? 2.4 is not so big. Let's use a 1-to-1 scale. So 1 centimeter equals 1 Newton. 1 centimeter equals 1 Newton. See the scale on the left? 1 centimeter equals 1 Newton. So now, I very intentionally put a really good angle between those strings. What do you think I did? What angle did I put between those? It's a really good angle to work with. Take a look at it. What do you think it is? Beautiful. I very deliberately, now I just like 80. That's not 90. That could be any angle. But you girls, I made it 90. Now, how do we make 90 in the middle? What are the two angles down here? If I can make it 90, what are these two angles over here? Yeah, 45, let's see. Yeah, 45 and 45. Can you do what we did before? Make the string forces 45 degrees from the dotted line to each protractor out.
I need a protractor.
Oh, I'm sorry, it's bad. Everybody put the curve what? Up and down, girls. Curve up and down. Up, curve up, beautiful. Everybody place the curve up and mark up 45, 45.
How many centimeters?
Okay, so just one by one, curve up, curve up. Look at me, girls, curve up like this. And mark up 45 on both sides.
Thank you.
Sorry about that. Mark up 45 on both sides. Very good. Well, let's do it step by step. Okay, everybody mark up 45, 45. So you get 90 in the middle. And let's do it. How long should each one of our courses be, girls, to be the 1-to-1 scale? Tell us, Ms. Bradbury.
2.4.
That's right. Let's make each course 2.4 centimeters, but do we label it 2.4 centimeters, or do we label it something else, Barry? That's right. Be careful. I've seen that on Regents, where first labeled at 2.4 centimeters, so that's 2.4 newtons. And put 90, beautiful job. Show this girl. And make it, mark it 90, you get to this, mark it 90 degrees in the middle. And then, because they're tail to tail, what shape are you gonna make with a dotted line? Because they're tail to tail. Kendra did such a nice job, but you make a parallelogram, right? So who wants to see how it's done? Opposite side of the both equal and parallel. Kendra did a nice job, so check it out. Everybody on the stage. Opposite side with arrows on the back. Let's just do 2.4.
Yeah. I'm gonna read.
So, 2.4. Anybody want to see how it's done? Very nice, careful job over here. See? Yeah, she did that. Check it out. Parallelogram, right? Beautiful work. That's beautiful. Well, I don't know. I've seen it less than in 30-something years. Like everywhere I look, I see beautiful drawings. Really nice drawings. You girls might be the best ever. Just, I don't see a bad one, and I'm not seeing one bad drawing. That's just never happens. You put arrows on below, see? Arrows on below. That's where your resultant vector is. Good. Now, let's put an arrow on our resultant, and label it resultant. Visibly, so put your arrow on your resultant, put arrows on all your forces. Yeah, up, put it right in the middle, which you do the resultant.
We put it up.
Yeah, you put it up. Let me show you on this sheet over here. So we're on page, this page over here. And I'm going to show you how you should be looking at. So you're looking at this. 2 forces of 2.4. I'm going to just sketch it because I don't have a protractor handy. This is 90 degrees. This is a terrible picture, by the way, 45 and 45 degrees. You have a protracted dotted line. Sorry for the imperfection of this. This is the resultant. Okay, resultant arrows on all three. Okay, now, what's missing from my picture? Guys, get my
Oh, amazing.
Sure. What's missing from my picture? The weight force, and it always goes straight. How big should it be? Because we're in equilibrium. What's that answer? Same as the resultant. So we do with the pencil. Let's draw weight force straight down. As big as the result because we're in equilibrium. Okay. So you can I show this around? Was I wrong? Did I be wrong? You see how it looks beautiful, weight force? Beautiful, beautiful. I won't give you something this hard on the quiz. This is hard. This is really hard. Who wants to see? Good weight force? Terrific. Boy, you girls look really good. Looking good. Weight force, good. Okay, so there's a whole lot of questions that we haven't answered. That's your job tonight. Doesn't look like a very big homework, does it? It's not, there are too many things that we have done, so tonight's homework is somewhat simple. I believe, I could be wrong, who looks ahead? It's always a couple students look ahead. Tonight you're going to do a self-evaluation. Did I get that right? Am I wrong? The self-evaluation week, we just check it out. Hold on. Let me go to here. Give me a second, let me see. Because a parent-teacher, after the Thanksgiving, parent-teacher's coming around. So that today's the 15th. No, I'm wrong. Tomorrow night, you have to fill out your self-evaluation. That is a sheet, just I asked you a series of questions and I asked you to answer honestly. You want to reflect on the work you've done this quarter, and you print it out after you answer it, and then you hand it in. And then when I talk to mom and dad, we look at that together and we talk about your progress, okay? So I was wrong. The self-evaluation is not tonight. It's to simply finish, do all the questions that we never got to. Together, so you can put that right now. Okay. When you do the last 2 minutes, that's what's wrong. And remember, girls, tonight, let's get to reading rules. Use your pencil only for pictures and plots. Everything else must be in pen. Yeah. Yeah, do everything that we can do. Just go page by page. Which questions did we answer? Like, get into the whole last page. Okay, girls. Do all the questions we need. You always get it. Okay, girls. Put it away. So do all the questions we skip that to the end. Hey, girls, let's get reading trained. Pencils are only the pictures and plots. Remember that when you do, because some of you are still using the pencil for a lot of things. So I want you to get the reading habits. Pencils are only the pictures and plots. Now get out the handout that you got a long time ago, because Miss Dunn, actually, wait a second, hold on. Let me see. You know that big packet? Let me see that big packet. Let me see if how was the last. Let me take a look at that big packet here. Oh, good. I'll tell you what, let's go to the big packet that looks like this. Now let's go to the very last page. Because you just have to do a little more. You got to do this big packet here with the last page. Very last page. Okay,
What does it look like?
looks like this. Really big package, looks like this. Worksheet on combining forces. Yep. Worksheet on combining forces.
What was the first thing Oh, yeah, I see.
So girls, go to the very last page. And what we do on the very, very last page, we can do a couple of you that's okay. But the very last page, and could you girls finish the bottom question? Because we did the drawing, so I want you to answer all those questions on the bottom. So the sheet looks like this. Say it's got a nice little graphic in the front. It says worksheet on combining forces. Very last page. So number 7. Now those of you who missed class, what did we already do? Well, we already put a protractor line through the dot. It's a horizontal line. And we already, hold on. We already drew the 6 Newton force. You don't have that sheet? Because I do have that sheet. Who doesn't have that? Looks like that. We did 6 Newton 30 degrees south of east. And girls, if your picture doesn't look like this, then you didn't do it south of east. Maybe you did it south of west.
How long is this gonna be?
6 centimeters, we're using a 1-to-1. Yeah, just pick somebody. Well, then you have to pick somebody. Pick picture. Okay, girls, does your picture look like that? And I'll just do, I'm not a protractor handy, but now, Wednesday, we're gonna have to find some components. And south of actually east, isn't it, girls? Yeah, southeast goes the other way. Right, east is to the right. Now, girls, which one did I tell you to draw first? Is it the vertical or the horizontal? Do you remember? Draw the what first? Which one? Vertical. So how do we do that? Well, we've got a force that goes south and east, so it certainly has a vertical component because, you know, it's part south and part east. So let's do the vertical first and call it Fy. And then we do the horizontal, we call it Fx. Okay? And a force that goes to the right has a right component, and the force that goes down, which my back does, has a down component. And label it, even when I don't ask you to label, because the readers will always ask you to label things, okay? Doesn't matter on the horizontal, just erase them. Okay? Even when I don't ask you, let's do regions ready for this picture. What great vector drawers here. I think we're going to get almost hundreds on every quiz. I really feel like because all I see is good work. All right, let's go, girls. Could you label your force? Let's call it 6 newtons. Okay? Ready? 6.0 newtons. All right, now the next thing we have to do with horizontal component. How do we do that, girls? There are 2 ways to find a horizontal component. One's super accurate, and one's pretty good. What's the pretty good method?
We use cosine.
To get super accurate, we can use cosine, right? Super accurate, we can use cosine. Fx equals F cosine theta, terrific. So Fx equals 6.0 newtons. Substitute with units, cosine of 30 degrees. And who knows the Fy to get super accurate? That's sine, right? So why don't you do the trick, substitute with units, and check your picture. How close is your picture to the perfect answer? How close is your picture to the perfect answer? your FX, that's why I would imagine they're gonna be really, really close. Because I'm looking at some good pictures. Now remember, you draw with a pencil, but you do everything else with a pen. Let's pick that pen up. Don't worry about what you've done with the pen. Let's get Regents ready. When we're doing, the Regents rules, let's get the pen out now to get into the habit so we don't make that big mistake and have our word that invalidated something like that. Because there's something that's supposed to be in pen, it's pencil. Yeah, I just stepped back and valid. I've seen that happen. Terrible. So let's get into the, okay? Do the rest of the day. All right, so we get into the good habit. So let's do our trade. Okay. Do our trade and see what else, how close our answers come. Arrows, I love all the arrows, big arrows on the beautiful pictures. Every single one of them. Beautiful pictures. So how did the picture hold up? Is it pretty good? When you measure them against the trig, did they become pretty close? Do you have to be perfect? Absolutely not. Can you be about 0.2 off? Yeah, that's pretty good. You don't have to be perfect. The readings gives you a little 0.2 plus or minus. Above or below the 0.2 what the trig gives you. If the trig is telling you something, I can adjust my picture, make it match the trig. So how did you do? Pretty close to the trig. Now, what did it? Can I just see? Did you girls end up getting 5.2 newtons in 3 newtons? Is that right?
Yeah.
Okay, now put the directions on both, please. So the x goes to the right and the y goes down. X to the right, or maybe I should say east is the x and south is the y. Now let's do a question that, the kind of question you'll see on my quiz. Ready? If the angle is increased, the vertical component will.
Wait, where?
So it's on the bottom there. See, increase is good. The vertical, if the angle is increased, the vertical will increase. And of course, if the vertical increases, the horizontal will decrease. That's logic, isn't it? If the vertical gets big, of course, the horizontal will get smaller. Now, could I actually the opposite? Could I say instead, if the angle would decrease, well, the answer would flip, wouldn't it? So you can do that hopefully Wednesday. All right. So let's set that aside. I know we have their answers, 0 o'clock, we haven't done. Let me see what we can do over here. How about you go? Can we do the tail? Let's see the head. Let's go to the previous page. Ready? The 5. Can you do 5? We're going to do a head to tail 5. What's a head to tail? It means when you begin the second vector off the head of the first. Everybody together, let's do 9 is north. Let's use, can we use a 1-to-1 scale? Would that work? 1-to-1? Oh, 1 to 2, okay, let's use, thank you. Let's use 1 to 2, this is what I gave you. So let's make a 4.5 centimeter 9 newton force. Let's do that. So make a little black dot in the middle. And 4.5 centimeters up, because that's what north is, right? So that's north. Yep. And we'll get good practice on a head to tail, which is really easy to do the head to tail. So 4.5 centimeters up, put a big arrow on it, and of course label it, which reads ready, label it. Okay. And then here's the cool thing. Where do you begin the next vector? From the head of the first. So we begin, no, that's tail to tail. Let's begin, this is head to tail. Did you circle that, girls? Head to tail. So when you look at it later on, circle head to tail, you'll know that why we did it such a weird way. The readings want you to know with tail to tail. Mostly they show tail to tail. But let's do this next one, head to tail. Begin the next vector from the arrow head at first.
How long is the horizontal?
Well, the next vector is 12 newtons east, so make it 6 centimeters long. But begin it from, let me show you what I'm talking about, hold on. Ready? So we did, let's go to the sheet. Let's go over here, let's find that sheet. that we're working on. Okay, where are you? Not that. Not you, not you.
Freshmen and sophomores may leave.
So before you go, some of you sophomores, all you have to do is complete the triangle like in the tip sheet. Just complete the triangle, one step, no parallel there. Beautiful, like this, nice show. Okay, terrific. Who wants to see? See, look, 5 minutes. See? Yeah, you begin the sentence, so begin that up there. See, that's Caleb. Put that over there. I'll tell you what, tomorrow, remind me to pull this up. Let's start this tomorrow. See? Head together. Beautiful. Yeah. Perfect. Good eye skills from you. Good job. So remind me to take this up tomorrow, please. Okay, stop this recording.